We are going to look at 6 tips to help improve your projects when working with scalable assets. Create a folder structure that is easy to use for all team members. Use naming conventions that are clear to all team members and adhere to them consistently through the project. This reduces the risk of file duplication, as each file will have a clear name and be stored in a single location. The folder structure and naming conventions should be chosen that best suit your project. Something that works for one project may not be suitable for a different project, so tailor it to your required needs. Here is an example that could work for a project. Keep animations, scripts, scenes and shaders in their own folders. Assets could be located in an art folder consisting of separate categories that could be architecture, props, vegetation and VFX assets. These folders can contain large, medium and small categories of prefabs. Within each of these are the materials, meshes, prefabs and textures. This makes it easy to locate and modify items when working as a team. File names could describe objects clearly, and for textures perhaps identify the type with an _A for albedo, _N for normal, etc. Modular assets could contain the size dimensions in their name, making it easier for designers to locate items quickly. The hierarchy could also be well organized, with static items placed in a root empty game object. Dynamic objects such as characters and cameras can be kept separate. Multiple project tabs can be opened, making it quicker to move between different asset types when laying out a level. For more tips on naming conventions, download the Create a C# Style Guide ebook from the video description below. Presets can save time in importing lots of assets, for example changing the normal map texture type automatically on import. To do this, click on the Preset button and choose Create New Preset to save the import values for a normal map. Now in Edit, Project Settings, we can open the Preset Manager and add a default preset importer of type Texture Importer. Add the normal preset you have just saved. Type _N in the filter to check if the name of the file indicates it's a normal map. Now when importing a normal map texture, it is automatically set up using the normal map texture type. And you can do this for any file type, which makes importing lots of files quicker and easier. If you only want to use one option in the preset, go to the top of the preset inspector, click on the 3 dots and choose Exclude All Properties. And now they are all grayed out and will not be used. Now right click on the option you want and choose Include Property, and that will be the only value that will be overridden when importing files. At the top of the inspector you can also click on the Add to Import a Default button, and this is faster than manually setting this up in the Preset Manager. We can also use the filter field to only apply a preset to files imported into a specific folder. Using the keyword glob allows us to use wildcards and special characters. The folder name I am using is test. The asterisk is used as a wildcard to denote any file name with an extension of FBX. You can also create a script which runs functions before and after importing assets. Use the Asset Post-Processor class and ensure the script is placed in an editor folder. This exposes a number of event functions. The onPreProcess functions run at the beginning as the asset is being imported. Then the onPostProcess functions run after the asset has been imported. We can achieve the examples seen earlier in the Preset Manager using PostProcess texture function. Check if the file name contains an _N, then getting access to the correct asset importer and converting to a normal map and setting the texture type to normal map. Or using preprocess model function to check for FBX files to generate secondary lightmap UVs. You can also set up your own custom rules and checks, such as in this example using the post-process model function to check the vertex count of the mesh filter and flag the item if it exceeds 30,000. Now if any FBX file has over 30,000 vertices, it will display a message with the total amount and identify the model by name. The Asset Post-Processor class can speed up the asset importing procedure. Unity supports a wide range of file types, but you may need to use a file type not currently supported by Unity. For this, you can use the scripted importer. In this simple example, a scripted importer is used to import a text file as a Unity asset. Ensure it is using asset importers, and it should inherit from the scripted importer class. When you override the onImportAsset method, you'll be provided with a parameter of type AssetImportContext. This context contains various import-related information and functionality. For instance, you can access the asset's import settings, file paths, metadata, and user-defined import options. You will need to write the custom import logic for this file type. This then reads the text from the file at context.assetPath and creates a new text asset with that text. It then adds this asset to Unity's imported assets using context.addObjectToAsset. Lastly, it sets the main object of the imported asset to the newly created text asset using context.setMainObject. This defines the primary asset that users will interact with in the Unity editor. For instance, when you import a .fbx file, the main object is typically a game object that holds the model, its materials, textures, and other related assets. Now this is just a simplified basic example. You can see real-world examples of the scripted importer in the package manager. The 2D ASprite graphics package imports sprites created using ASprite software, and the 2D PSD importer works with Photoshop files that retain layers. And the Alembic imports alembic.abc animation files, which are high-quality vertex-based animations for simulations such as water, cloth, hair, etc. Once you have imported these packages, you can find the scripted importers for each of these packages and see how these scripts are written to handle those file types. Prefabs can often be updated by the art department. To protect the modifications you make as you are designing your levels, use prefab variants. Variants will still inherit any changes from the original prefab, but without affecting any of your modifications. Right-click on a prefab in the Project tab and choose Create Prefab Variant. Notice the variant has an icon with stripes on one side. This can now be added to the scene and modified. Applying overrides will update the variants only. Components and scripts can be added to the variants. Now if the art department brings in new 3D meshes and overwrites the original prefab, it won't affect the modifications you have made on the variants. The changes will update automatically and the components or scripts will be unaffected. You can also create material variants, so the variant will inherit the changes to new textures if other team members update the original material, but without affecting any changes you have made to the variant. You can assign any of your game objects to an addressables bundle and control when they are loaded into memory. This speeds up the loading process for levels. You can also unload any assets when no longer needed, freeing up memory. Make a prefab of the object you want to load into a scene. Now create an empty game object so it spawns in at the right location. The object can now be deleted out of the scene. We will load it back into the scene during play mode. The addressables package should be installed from the package manager. Go to Window, Asset Management, Addressables and Groups. The object prefab can now be added to a group and given a label. Go to Build and Default Build Script. This now creates the addressables bundle for the prefab that we can load into memory. A script can be created to handle importing addressable asset bundles. First ensure it is using addressable assets and async operations. A function handles the importing of asset bundles asynchronously, so the game is running while the bundle is being loaded into memory. This can reduce long loading times for levels. Once the asset bundle is loaded, it then runs another function. If the async operation was successful, it then instantiates the bundle at the spawn point in the level. If the async operation wasn't successful, then we display a message in the console. Now we can call the asset load function. This can be called from anywhere, for example at the start. The tent area in the scene is empty. We want the tent asset bundle to load in during gameplay. We identify which bundle to load in by its label and set the tent spawn point. Now during play mode, the tent loads into memory and then into the game. This is great for big open world games where importing all assets into memory during the loading of a level is not possible. So during gameplay, assets can be loaded and unloaded from memory as the player is playing the game. Unity offers an artist-friendly, easy-to-use version control system integrated directly into the editor. Version control ensures that you can work independently with an updated workspace combining all team members' updates. When creating a project in Unity Hub, you can connect to both Unity Cloud and version control. If you've already started a project, you can click on the three dots and connect to version control from there. Click the version control button to open the version control panel. I can change the player's starting position, save the scene, and now this shows up in the pending changes section. Leave a short, clear message of what you have changed and check in that change. This will now show in the Change Sets tab, so you can keep track of all the changes made by all team members. If another team member adds another item, for example a point light, and checks in that change, this will now show in my Incoming Changes tab. I can update my workspace and their changes will be added to my scene, making version control easy and quick to use. It also supports a branching system, so you can freely move back and forward to any change point. Team members can create their own branches before merging with the main change point. Check out the link in the video description below to learn more about Unity version control. Download the ebook found in the video description below for more great Unity tips. Thanks for watching.